In these notes, we're going to take a look at how to find the volume of prisms and cylinders. So to start, let's take a look at the warm-up. It says, how many cubes measuring 1 centimeter on each edge will fit into the container? A box measuring 2 centimeters on each inside edge. So if we talk about that, there would be 8 cubes on that, because you'd have 2 cubes. So if you think about a box, let's just pretend over here, you'd have 1 cube and then 1 cube. I know that doesn't make any sense with the way I'm drawing it, so you have 1 cube and 1 cube, another cube. So you'd have 2 cubes here and 2 cubes on the base, so that's 4, and then you have 4 more on top of that, so that'd be 8. And if you look at a box that's 3 by 4 by 5 centimeters, it would be 60 cubes. Okay. So in real life, you encounter many volume problems. You can come across these at the grocery store. If you're looking to see which price is the best price for which product, you can compare the volumes and see how much it is per volume unit when you're looking at a store. Like, for instance, if you're looking at peanut butter, which peanut butter is the best price. And then you might also come across this in a job. Engineers are asked to calculate the volume and weight of sections of a bridge to avoid putting too much stress on any one section. Chemistry, biologists, physicists, they all make use of volume. Carpenters, plumbers, and painters, they all use volume as well. Now, volume is the measure of the amount of space contained in a solid. So you're going to use cubic units to measure volume. Cubic inches, cubic feet, cubic yards, cubic centimeters, cubic meters, etc. The volume of an object is the number of unit cubes that completely fill in the space within the object. So for instance, this is a unit cube. All right, the volume is 1 cubic unit. So what you're really doing is you're asking yourself, if I want to fill in this shape, how many of these cubes fit inside of there? And so you can see you have whole cubes, but then you also have partial cubes that you have to take into consideration. So it wouldn't be the best idea to sit here and count all of these cubes, because especially when you start getting these partial cubes, you don't know if they are really half a cube or a fourth of a cube, so you'd have to start making estimates. So what we did is we came up with some ways to find the volume of different shapes rather quickly using equations. So if you look at this investigation, the first thing it would ask you to do is to find all the cubes inside of each of these shapes, A, B, C, and D. And if you look at letter A, that one can be kind of easy. You could do this one just by counting 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 cubes there, and then that would mean there's 8 cubes in this layer and 8 cubes in that layer. So you'd have 3 sets of 8, which would be 24. So it'd be, the volume of that would be 24 cubic centimeters. But then that gets to be kind of tedious when you start getting larger shapes with smaller cubes. So then at that point, we would need to come up with a quicker way to find that volume. And what you may have noticed here is that what we did is we found the number of shapes, or the number of cubes that were in that top base. And then basically what we're doing is we have that layer repeated 1, 2, and 3 times, which is the height. So essentially what we did is we found the area of the base, and then we multiplied it by however many layers there were, which was the height. So if we do that, and looking at B, you have a base down here that is 3 by 12. So 3 times 12 would be the area of the base. And then there are 8 of those because the height is 8. So 3 times 12 times 8, that'd give us 36 times 8, which is 288 cubic centimeters. And then the same thing over here. You have 10 times 30 times 10. So you have 300 times 10, which would be 3,000 cubic centimeters. And so what we're really doing is we're finding the area of the base and then multiplying it by the height, because that is how many times that base is sort of, in a way, if you visualize that, being translated up to create the other layers. So what I want you to notice is that the number of cubes resting on the base equals the number of square units in the area of the base. And then the number of layers of cubes equals the number of units in the height. So what we did is we multiplied the area of the base times the height of the prism to quickly find the volume. And what that allows us to do is to have this equation for the rectangular prism volume. And what it says is, if B is the area of the base of a right rectangular prism and H is the height of the solid, then the formula for the volume is V equals B times H, where you're finding the area of the base and multiplying it by the height of the prism. And what we can then do is we can take that and use it to talk about how to find the volume of any prism that has a parallelogram as its base, a triangle as its base, a trapezoid as its base, or a circle, and a circle would be a cylinder. And we talked about how we can turn those shapes into rectangles. And that means what we can do is we can extend this conjecture into the conjecture for all right prisms and right cylinders. And so what that means is regardless of the shape of the base of your prism, or if you have a cylinder, you are always going to find the area of the base times the area, or times the height. So if you have a cylinder, you would find the area of the base, and that would be pi r squared. If you had a triangle for your base, the area of that base would be 1/2 base times h, or 1/2 base times height of the triangle. So the next question that we would want to ask ourselves is, well, what happens if we have an oblique prism or cylinder? And the way we'll discuss this is we'll say, let's take a look at a oblique rectangular prism here, and let's visualize that as a stack of 3 reams of paper. And you can see it's kind of offset, so it's not perfect. It's not a right prism. It is an oblique prism. And we can agree that if we take all this paper and if we were to sort of tap it or nudge it that way so that it became a right prism, that those 2 objects would have the same volume. The shape changed, but the volume did not, which is what we have highlighted right here. Okay, the shape changes, the volume doesn't. So since the volume hasn't changed, what we can say is that if you have an oblique prism or cylinder, that the volume of an oblique prism or cylinder is the same as the volume of a right prism or cylinder that has the same base area and same height. So as long as the base is the same and as long as the height is the same of those 2 objects, you can still find the volume of an oblique prism or cylinder by doing area of the base times the height. Finally, what we can say is the prism cylinder volume conjecture. So what we can finally say is that the volume of a prism or cylinder, regardless of if it's oblique or right, is the area of the base multiplied by the height. So let's go ahead and just do a few examples of this. Here it says we have find the volume of a right trapezoidal prism. So this means that the base is a trapezoid, and it says that it has a height of 10 centimeters. And it says the 2 bases of the trapezoid measure 4 centimeters and 8 centimeters, and its height is 5 centimeters. So again, you can see right here, initially you might think that this is your base down here because it's resting on that, but it does say it's a trapezoidal prism, so that means that your base is a trapezoid. So we know that if we want to find the volume of any prism, the volume is equal to the area of the base times the height. Well, let's do our work off to the side. We know the base is a trapezoid, and the area of a trapezoid is 1/2 base 1 plus base 2 times the height of the trapezoid. And that information is given to us. We know the bases are 4 and 8, and we know the height of the trapezoid is 5. So we have 1/2 times 12 times 5, which gives us 30. So the area of the base of this trapezoidal prism is 30 times the height. It tells us that the height of the prism is 10 centimeters. So we get 30 times 10, which is 300 cubic centimeters. Now, let's take a look at the next one. It says find the volume of an oblique cylinder that has a base and a radius with a radius of 6 inches and a height of 7 inches. Again, even though it's oblique, we still know it's the area of the base times the height of the cylinder. If we do work off to the side, we know that the area of the base is a circle, so pi r squared. It tells us the radius is 6 inches, so we have 6 squared times pi, which is 36 pi. So the area of the base is 36 pi times the height, which is 7. So 36 times 7 is equal to 252 pi cubic inches for the volume. Now, one last example. It says find the volume of a semicircular cylinder with a radius of 8 centimeters and a height of 12 centimeters. Semicircular tells us that this is half of a cylinder, half cylinder. So we can find the volume. So what we want is the volume of a cylinder, but we only want half of it. So we're going to do half times base times height. So if we do this off to the side, we know that the base of this is a semicircle, but we'll take that into consideration when we multiply by 1/2. So it's pi times the radius squared, which is equal to 64 pi. And so we have 1/2 times 64 pi times 12. So we have 1/2 times 64 is 32 times 12. We get 384 pi and then cubic centimeters as our volume. So that is a quick rundown of the volume of prisms and a cylinder. Again, remember it's the volume is equal to the area of the base times the height of the prism or cylinder. So go ahead and begin working on the homework. If you have any questions, feel free to message me or ask them in class today.